All right, welcome back to part 2 of lesson 2.3. So part 1, we just talked about kind of the tutorial part, the instructional part of it all. Typically every year when we're talking about quadratics and factoring them, this is a little bit of a difficult unit for some students, partially because you talked about this 2 years ago in Algebra 1. So it's been a little while since you've kind of factored or dealt with GCFs or things like that. So there is a little bit of legwork that has to be done with students most of the time. Some students can kind of see it and it comes back to them and it jogs their memory pretty quick. But if you are struggling when I say GCF, if just that review from part 1 didn't make sense, if the review from those two different types of factoring, the box and cross or the slide divide bottoms up, didn't make sense, and you're trying it, please reach out to me and I'd be happy to stay after class or do a Zoom call with you and just kind of walk you through it till you get a few under your belt. And then I think the more you practice this, the easier it gets. So we'll start off with number 17. They want us to factor each of these expressions. So notice number 17 is dealing with expressions. Well, I guess you could say 17 through 23. And then the next section actually has equations. So when you're dealing with expressions, like with number 17, where there's no equal sign, you can't solve for x. All you can do is factor it. So basically what we're going to do is rewrite 17 as a set of parentheses being multiplied by each other. You're not going to answer it x equals this or x equals that. So with 17, I think I'm going to go ahead. I think for one of these, I will use the box method, and one of them, I will use the slide divide bottoms up. Actually, we'll do two. We'll do two. So 17 and 18, I'll use the box method. 19 and 20, I'll use slide divide bottoms up. And pretty much from there on out, I'm just going to use slide divide bottoms up because it's less ink, it takes up less space, it goes a little bit quicker. But let's look at box and cross with 17 and 18. So if you think back to your notes, hopefully in part 1, you kind of made yourself a little side note of how all those steps for factoring works. If you didn't, pause this, go back, write down those steps so that way you have them available to you. But the first step is if you were factoring with an equation, you want to make sure it's equal to 0. Again, this is just an expression, so we're not doing that this time. The second one is make sure it's in standard form, which it is. X squared is first, then our x term, then our constant. The third step is to take a GCF, a greatest common factor. So when I look through these three terms, I'm looking to see if I can divide each term by an x or if I can divide each term by a number. Since not all the terms have an x, because this negative 10 doesn't have an x with it, I can't take out a GCF of x. And then all of my coefficients are 1, -3, and -10. Nothing is shared between those three numbers, so I don't have a GCF. Again, when I say that GCF, if what I've said so far doesn't make sense, please go on YouTube, search what is the greatest common factor, what is the GCF, how to take the GCF, something like that. Because that's an important part of these steps. You got to understand what a GCF is and how to take it. So now I'm ready to do the box and cross steps. So there is my x. I'll draw my box as well. And if you remember from those notes at the top, a times c is up top and then b is down below. So in this case with number 17, a is 1. So a is just the number in front of x squared. B is -3. B is just the number in front of x. And then c is -10. It's just the constant at the end. So a is 1, b is -3, c is -10. So at the top, a times c, that's -10. At the bottom, b is -3. So at this point, this is where you're trying to think of two factors that multiply to AC and add to B. Typically, there's lots of factors that are going to multiply to AC, but there's only going to be one pair of factors that add to B. So like in this case, -1 times 10 is -10. 1 times -10 is -10. But it doesn't matter which example I look at. When I add those two numbers together, they're not going to equal -3. What about -2 times 5? That's -10. And 2 times -5 is -10. So -2 times 5, that works, but -2 plus 5 is +3. So I think we're in the right ballpark with those numbers. We just kind of have to manipulate the negative a little bit. So what about 2 times -5? That's -10. And 2 minus 5 is -3. So those are my two factors I want to choose. 2 and -5. Remember, it doesn't matter if the 2 goes on the left or the right. The placement doesn't matter. They just have to be there. And then I'm going to go over here to my box method. So again, if you forgot with how this works, go back and make sure you're taking notes throughout that tutorial part. The top left corner, that's my A term. So my A term is 1x squared. The bottom right, that's my C term. So in this case, it's just -10. And then my two other boxes, it doesn't matter which one goes where. I need my 2 and my -5. Again, I could have put -5 down here, 2 up there. It doesn't matter. But just remember, you have to add in an x here. I need to have an x with both of those terms. All right, so now I'm going to GCF. I'm going to take out the greatest common factor from each row, and I'm going to take out the greatest common factor from each column. So row 1, it looks like they don't share a number, right? That's just a 1, that's a -5. But they both have at least one x I can take out. So I'm going to take an x out of both of those because that has 2 of them, that has 1 of them. A greatest common factor means it's got to be common in both terms. So even though that has 2 x's, this doesn't have 2 x's. So I'm not allowed to take out 2 x's. The second row, 2 and -10, both of those numbers are divisible by 2. So I can take out a GCF of 2. And then the first column, x squared and 2x, both of those numbers can be divided by x. And then the second column, both of those numbers can be divided by -5. Why am I choosing -5? Now that I look at this, I'm going to rewrite this real quick because I want to emphasize something. I ran out of room on the left, so that's why I kind of wrote these things on the right. Okay, so typically when you're GCFing something, you're taking something and you're writing it on the left side, or you're taking something from the column and you're writing it on top. Here, when I took out this GCF and it was a GCF of 2, same thing with the top row, it was a GCF of x. You want to make sure that those signs match. This is a positive, so this has to be a positive. This is a positive, so this has to be a positive. Same thing with the first column. I took out an x, that's a positive, so that's a positive. The second column, I could take out a 5, but because that box is negative, this term has to be negative. It's just kind of the way the process works. So if you run out of space like I did, maybe just redraw your square so that way you can always GCF out to the left and you can always GCF out up top. So here's my factors. That's a positive x, and that's a positive 2, so it's x plus 2. That's a positive x, and that's a -5, so it's x minus 5. So for number 18, 18 is 3x squared minus 5x minus 12. I kind of referenced earlier that this is sometimes a difficult unit for people. I think along with not seeing this stuff for 2 years since you were in Algebra 1, the other problem is that there's lots of steps. And you can kind of see that with just my work from 17. Typically, when students get introduced to a concept that takes a lot of steps, that just kind of means more work. So your work ethic has to be high. And once students start looking in here and then there's all these steps and all, people get distracted and kind of quit. And they don't give themselves the chance to work through it. So stick with it, keep working through it. Again, practice makes perfect with these kind of things. Let's do, again, box and cross method, and then we'll do slide, divide, bottoms up for everything else. So step one, it's not an equation, so it's not equal to 0. That's fine. Step two, it's in standard form. Step three, there is no GCF. Step four, I'm ready for box and cross. Okay, give myself a little bit of room there. So at the top, it's A times C. At the bottom, it's B. Once you do these and once you get used to doing them, 3, 4, 5, 6 problems into it, this is going to go super quick. It looks like a lot of work, but you're just going to automatically draw that stuff, A, C at the top, B down below. Another thing that tends to trip people up is if your multiplication facts are weak. If I tell you, what's 7 times 8 and you're drawing a blank, that's going to make this unit very difficult. Obviously, the stronger you are with your multiplication facts, the easier it's going to be to come up with those two numbers that multiply to -36 but add to -5. Again, if you have weak multiplication fact skills, that's okay. Just do what I did up with 17. List out those possible factors and just go through them one at a time. So in just a few minutes, once we start doing more problems, I'm just going to throw out the two factors if I can think about it in my head. But right now, I'm going to start listing them out. So what multiplies to -36? -1 and 36? Or it could be 1 and -36. But is there any way to add or subtract or do anything with those to get them to be -5? No. So what about 2? 2 times what, 18? And -2 times 18. So 2 times -18 or -2 times 18, that's 36. But again, if I add those together, there's no way it's going to get to -5. 3 and 12. So I should say 3 and -12, and then -3 and 12. They multiply to -36, but they're not going to add to -5. So 4 and 9. I think I'm in the right spot here. I think 4 and 9 are my right numbers. I just got to figure out the negative. So -4 plus 9 is +5. So 4 and -9, when I add those together, that's -5. So you can see that takes a minute to kind of process. Of course, like I said, the stronger you are with multiplication facts, the quicker this will go. But if you're not that strong, that's not an excuse. Just kind of keep those things listed out over here on the right. Use a calculator if you need to, and that will get you to the right answer. So 4 and -9 are my two factors. Now I'm going to go over here and plug them in. So my A term goes up top. My C term goes down in the bottom right. And then those two factors, along with an X, goes in those other two boxes. It doesn't matter which box. So now I'm going to take out the greatest common factor. So with the first row, 3 and 9, 3 and -9, I think both of those can be divisible by, or they can be divided by 3. Right? 3 divided by 3 is 1. -9 divided by 3 is -3. Then there's an X squared and an X. So in this case, we're actually going to take out an X as well. So here's an example where we're taking out a number and a variable. That can happen. Sometimes you'll take out just a number or just a variable. Sometimes you won't be able to take anything out. So you're just going to take out a 1 as a placeholder. But because 3x squared is positive, because the box that it's next to is positive, this has to be positive. So row 2, what's common between those two numbers is just a 4. And again, 4x is positive, so this is positive. The first column, there's nothing common between 3 and 4, but there is an x that I can take out. And then the second column, what's common between -9x and -12? I think that's going to be a 3. But remember what we said about the sign. That 3 is butted up against this box. This box is a negative. So that has to be a negative as well. So my answer, positive 3x plus 4. And then the other factor, x minus 3. All right. Let's take a look at 19. So from here on out, for the most part we're going to be doing slide, divide, bottoms up. Not for any specific reason, just because, again, it goes a little bit quicker in my head. So That's what we'll look at. So for number 19, again, make sure those first three steps are satisfied. If it's an equation, make sure it's equal to 0. Make sure it's in standard form. And if there is a GCF in those three terms, you've got to take that GCF out. So the next step, which all of those are good to go. So the fourth step, I'm going to set this up with the cross. A times C goes up top. B goes down below. So exactly like these last two problems, right? So far, it's the exact same. Two numbers that multiply to 56 and add to 15. I think that's 7 and 8. So here's the part where it kind of changes, and you can go back and reference those steps or those the steps that I wrote out with the last example or in the last video. At this point, once I identify those two factors that multiply to 56 and add to 15, here's the step where I want to divide both of these by that A value. So in this case, A is 1, so I'm going to divide them both by 1 and simplify. 7 divided by 1 is 7. 8 divided by 1 is 8. So now I am ready to write this as a set of factors, the set of parentheses. So this is a positive 7, so it's going to be x plus 7. This is a positive 8, so it's going to be x plus 8. So you can see how that was a bit quicker, right? It's got less steps than the box and cross. Some people have just been taught box and cross, so they stick with it because they're familiar with it. This slide divide bottoms up actually works pretty well. So let's look at 20. 20 is 2x squared plus 7x minus 15. Again, not an equation, so I'm not worried about step 1. Step 2 is it's in standard form. Step 3 is there's no GCF. There's not a greatest common factor that I can take out of those three things. We'll see that later on, though. So I'm going to draw myself a cross. A times C goes up top, so 2 times negative 15. B goes down below. So two numbers that multiply to negative 30 but add to 7, I think that's going to be 10 and negative 3. You can see how quick these go, the more familiar you get with it, and then also the better you are with your multiplication facts. This can go fairly quick. Here's the part with the slide divide bottoms up that's different than that box and cross method. I've got to go back and divide by A. So I need to divide everything by 2 and simplify. 10 divided by 2 is 5. Negative 3/2 can't simplify. So the next step is to write these as parentheses, as factors. So that's a positive 5, so it's x plus 5. That's a negative 3/2, so it's x minus 3/2. And then like we said back in the instruction part of this, you don't want to leave that as a fraction. You don't want to leave that as a negative 3/2. This is that part of slide divide bottoms up that comes into play. So this bottom, this denominator is going to come up as that leading coefficient of that x term inside that parentheses. So x plus 5 is still there. But now this 2 is going to come up as the coefficient to x. And because it's minus 3, I'll write 2x minus 3. Now, with that said, most people you're going to get so used to that, you're not going to write this step out. You're just going to look at that and say, okay, x plus 5. You're going to look at that, and in your head, you're going to take that 2 and kick it up top. So you'll write 2x minus 3. That's fine. Don't feel like you have to write that step. I'm just doing that to emphasize what I'm doing with bottoms up. All right. So now we could probably go a little bit quicker through these. So let's take a look. 21. 3x squared minus 18x minus 48. So again, I'll kind of start going a little bit quicker, but still trying to explain the steps. So if I'm losing you with 21, rewind the video and go back and kind of watch the other ones a little bit slower. Step 1, I don't need to do it because it's not an equation. Step 2, make sure it's in standard form, which it is. Step 3, take a GCF, which I need to. If you look at these three terms, only 2 of them have x's, so I can't take an x out. But I do have a GCF when it comes to numbers. If you look at it, that 3, I can divide all 3 of these terms by 3. 3 divided by 3 is 1. Negative 18 divided by 3 is negative 6. Negative 48 divided by 3 is what? Negative 16. So 3 is going to be my GCF. So if I GCF out the 3, basically I'm just dividing each of these terms by 3. So I'll have x squared minus 6x minus 16. And now I'm ready for the slide divide bottoms up. So AC at the top. Remember we talked about back in this tutorial, this 3 is just going to kind of come along for the ride, but it's not actually going to play a part in finding this information. So for right now, you can just ignore it. So at the top, A times C, A is 1, C is negative 16, B is negative 6. Two numbers that multiply to negative 16, but add to negative 6. I think that's going to be negative 8 and positive 2. Again, if you're struggling with coming up with those factors, just take some time and write out all the factors of 16, write out everything that multiplies to 16, in this case, negative 16. And then as you're writing them out, just check them and see if they add to negative 6. Now's the part where I'm going to go back and divide by A. In this case, A is 1. And then simplify. So nothing really changed. It's still negative 8 and 2. And now I'm ready to write that final answer. So here we go. Negative 8, so it's going to be x minus 8. Positive 2, so it's going to be x plus 2. Here's the part that you got to remember, though. At the beginning, we took out that GCF. So even though the GCF didn't play a part in finding these zeros, you still have to include it with your final answer. If you don't include that 3, it's going to be a totally different answer. It's not the same thing as that quadratic that you started with. So always jog your memory, take a second once you solve that, especially now that we're looking at GCFs, make sure you're including, if you took out a GCF, make sure you include that with your final answer. Otherwise, it won't be correct. 22 is 4x squared minus 11x minus 3. It's not an equation. It's in standard form. There's no GCF. So I am ready for my x. 4 times negative 3 is negative 12. Negative 11's at the bottom. Two numbers that multiply to negative 12 and add to negative 11 are negative 12 and 1. At this point, with slide divide bottoms up, we got to go back and divide by A. And always simplify if you can. Negative 12/4 is the same thing as negative 3. 1/4 is just 1/4. You can't simplify that. So it's going to be x minus 3, because that's a negative 3. That's a positive 1/4, so it's x plus 1/4. And then the kind of ending of this whole slide divide bottoms up is if I'm left with a fraction in my denominator, I've got to take that denominator and slide it over and put it up in front of that x term. So my final answer is still going to be x minus 3. That 4 is going to come up in front of the x. And because it's plus 1, it'll still be plus 1. Uh, 23. Y equals 3 parentheses x minus 5, x plus 4. And it wants to know what the zeros are, what the x-intercepts are, what the roots are. Remember, all those things mean the exact same thing. So what they're doing is they started off with some type of quadratic like they did here with number 22, but they did all the work for you. They went through all the steps, they did slide divide bottoms up, and they're giving you this as an answer. But what they want you to do is interpret what the zeros are. And if you think back to our video tutorial from part 1, what we do is we set each of those factors equal to 0, okay? So right now, there are 3 factors. There is 1 right there, there's number 2, and there's number 3. Okay, right now we have 3 factors, three things that are being multiplied. But the thing is, with factor number 1, there's no variable there. Okay, there's nothing there. If that was 3x or 3x squared or something like that, then I would set that equal to 0. But there's no variable. So when I put 3 equal to 0, it doesn't really make sense. I can't solve that. I can't do any math to get x equals something. So that's not a step. We're not taking this factor and setting it equal to 0 because there's no x there. But these do have x's, right? These factors, these things that are being multiplied. So I'm going to take x minus 5 and set it equal to 0. And then I'll take the other factor, x plus 4, and set it equal to 0. So now I'm just ready to solve it. I'll add 5 to both sides, so I get x equals 5. I'll subtract 4 from both sides, so I get x equals negative 4. Once you start doing these over and over and over, you're not even going to have to do this. You're not even going to have to write these down. You're just going to look at this and just be like, oh, well, it's just going to be, since it's just 1x minus 5, it's just going to be the opposite of negative 5, which is positive 5, right? Because 5 minus 5 is 0. Same thing over here. Negative 4 plus 4 is 0. So that's why x equals negative 4. But until you get to that point, please write these steps down. It's going to help you visually process all this stuff. 24. Now we're doing quadratic equations. So exactly what we just did at the beginning, but now we're actually solving. We're going to get x equals this and x equals that. So x squared minus 5x minus 14 equals 0. Step 1 is done. It's equal to 0. Step 2 is done. It's all in standard form. Step 3 is done. There is no GCF. So step 4. A times C, that's negative 14. B is negative 5. Two numbers that multiply to negative 14 but add to negative 5, I think you're going to be negative 7 and 2. Once you choose those numbers, I always take a second just to double check. So is negative 7 times 2 negative 14? When I add negative 7 and 2, does it equal negative 5? Always double check yourself, otherwise you're going to be on the wrong path. Now's the part where I'm going to go back and divide by A. So divide by 1 and simplify. Again, when you divide by 1, nothing changes. So if you don't want to do that step where you write divided by 1, you don't have to. I'm just doing that to emphasize what we're doing. So my two numbers are negative 7 and 2. So think back to that video tutorial from part 1. One option I told you to do was this. If you're solving for this equation and you're trying to come up with the x-intercepts, just take the opposite of those two numbers. After you pick your two factors, after you divide by A and simplify, just take the opposites. So this is the opposite of negative 7 is positive 7. The opposite of positive 2 is negative 2. So that's the quick and easy way of doing that. But let me kind of emphasize why that works and walk you through it. So I'll do this for number 24, and then from here on, I'll just do the quick and easy way. So what we did from this step, once we chose our two factors, is we'd write it out. This is a negative 7, so it's x minus 7. This is a positive 2, so it's x plus 2. And again, we started with an equation equal to 0. So just like we talked about in number 23, what you want to do is take each of these factors, each of these things that are being multiplied, and set them equal to 0. So I'm going to do x minus 7 equals 0, and then x plus 2 equals 0. And now we just solve for x. So I'll add 7 to both sides. I'll subtract 2 from both sides. And you notice we get the exact same answer. So again, your choice. If you're one of those steps people and you want to work it out, more than welcome to. Just a little bit quicker to just take the opposite of those two numbers. See if we could squeeze 25 in there. So it's x squared equals 5x minus 6. So I think we had an example like this a little bit ago where it's not equal to 0. So step 1, we need to have this equation equal to 0. So I think what I'm going to do is subtract 5x from the right and from the left. I'll add 6 on the right and on the left, because now on the right, 5x minus 5x is 0, negative 6 plus 6 is 0. So on the left, I still have my x squared. I've got a negative 5x. I've got a positive 6. And now it's equal to 0. All right. So step 1, it's done. Step 2, it's already in standard form. When I rewrote it, I made sure I put it in standard form. Step 3, if it has a GCF, make sure you take that GCF, which it doesn't. So I think I am ready for my cross. A times C, B. Two numbers that multiply to AC but add to B are going to be negative 6 and 1. My A value is 1. So again, you don't have to do this step because when you divide things by 1, it stays exactly the same. Nothing changes. So since I'm solving this, again, you could do what we did here and you could write it out, but just take the opposite. Make it easy on yourself. This is a negative 6, so it's x equals positive 6. This is a 1, so it's x equals negative 1. Make sure you're taking the opposites. That's important. The opposites. (26). All right. So there's number 26. It's not equal to 0, so I'm going to have to do some algebra here. Subtract 3x from both sides. Then I get 3x squared. If you write minus 60 and then minus 3x, you're going to have to flip those around. So as I'm writing this, I'm going to put it in standard form. So there's a negative 3x, and then there's a negative 60. So it's in standard form. So just by doing step 1, I'm automatically doing step 2 when I put it in standard form. Step 3, look for a GCF. I think all 3 of these terms are divisible by 3, so I can divide them all by 3. This is going to leave me with x squared minus x minus 20. So I'll draw my x over here. Again, just kind of ignore this GCF. You've got to include it at the end with all your scratch work, but right now when you're calculating your x-intercepts, it doesn't play a role. So A is 1, B is negative 1, C is negative 20. So A times C at the top, B down below. Two numbers that multiply to negative 20 but add to negative 1 are going to be negative 5 and 4. This time I'll skip dividing by 1 because again, it's just more stuff on your paper. You're wasting ink. But when I divide by A, that's just dividing by 1. So my answers are going to be positive 5 and negative 4. Again, finding these x-intercepts, getting those answers, taking the opposites, it doesn't involve your GCF. So if you were continuing to write your scratch work out like this, if I wanted to write out my parentheses, I would have to put 3 and then x minus 5, and that's x plus 4. And if I wanted to keep showing all my work like I did a couple problems ago, you'd want to make sure that 3 is with that. Because if I don't write that, now you've got a totally different quadratic. It's not the same thing. But just solving for the x-intercepts, that 3 doesn't play a role in it. 27, 5x squared plus 12x equals 9. So we'll go a little bit quicker. It's got to be equal to 0, so I'm going to subtract 9 from both sides. It's in standard form. There is no GCF, so I'll jump right over to the cross method. A times C at the top, B down below. What multiplies the negative 45 and adds to 12? 9 and 5, 15 and 3. So I think it's going to be positive 15 and negative 3. So you could see there, I started with 9 and 5. That's kind of my go-to factors for 45, but there's no way to add or subtract 9 and 5 to get to 12. So then I thought of 15 and 3. Those are 12 apart, right? And they multiply to 45. I knew one of them had to be negative. So in order to add those two numbers where you add to a positive 12, The 3 has to be negative. So now I'm going to go back and divide by a and simplify. Always simplify. 15 divided by 5 is 3. So here's my answer. One of them is going to be x equals -3, right? The opposite. And the other one is going to be x equals positive 3/5. All right, 28. 4x squared plus 3x minus 7 equals 0. It's equal to 0. It's in standard form. There is no GCF. A times C, that's -28. B is 3. Two numbers that multiply to -28 but add to 3, I think are going to be 7 and -4. Don't forget, coming up with those factors could be difficult sometimes. Not necessarily always, but sometimes you might have a product where it's difficult to think of two factors. So list those out on the side if you're struggling with that. There is no secret behind that. There's nothing I can tell you. You can grab a calculator and do 28 divided by 2, 28 divided by 3, 28 divided by 4, and you can keep looking for it that way. But other than that, there is no trick to coming up with those. You just either have to use a calculator or you have to be solid in your multiplication facts. I'm going to go back and divide by a and simplify. And now I am ready for my answer. This is x equals +1. This is x equals -7/4. So you can see how the slide divide bottoms up can save you a lot of ink. It could save you some time, especially once you get good at it. You know, sometimes there's not any scratch work, 28 compared to 27, right? We didn't have to do anything with 28. But just stick with it. You'll get more and more comfortable with it. 29. 6x squared equals 5x plus 6. It's not equal to 0. So I'm going to go ahead and subtract 5x from both sides and subtract 6 from both sides. That way my right side of my equation is equal to 0. And on the left, I've got 6x squared minus 5x minus 6. So it's in standard form. There is no GCF, so I'm ready for my cross. A times C at the top, B down below. Two numbers that multiply to -36 and add to -5 are going to be -9 and 4. My A value is 6, so go and divide by 6 and simplify. You'll notice that 4 divided by 6, that's not like it divides and it's an integer, but you can reduce that, right? 4 divided by 6 is the same thing as 2/3. -9 divided by 6 is the same thing as -3/2. So it's not always going to simplify to like an integer, like a whole number. You might just have to reduce the fraction down, but always look to reduce. That's key. Otherwise, your answer is not going to be correct. It's just a step in the process. So my answers, that's a -3/2. So it's x equals +3/2. That's a +2/3. So it's x equals -2/3. So number 30, let me go ahead and put this over here because it's kind of a lot to read. A penny is dropped from the top of a new building. Its height in feet, I don't know why it matters that it's a new building. Its height in feet can be modeled by the equation y equals 256 minus 16x squared, where x is the time in seconds since the penny is dropped. How long does it take for the penny to reach the ground? All right. Essentially what they're telling you here is factor it. I mean, that's the main idea of this whole lesson, so it kind of makes sense they want you to factor it. So I'm going to start off with that equation, y equals 256 minus 16x squared. But I'm going to rewrite this just because I don't like to look at it with the y value on the left and it's not in standard form. So I'm just going to kind of rewrite this. I'm going to put the y value on the right. And then I'm going to rewrite this equation in standard form. So the x squared is going to come first. and then that 256 will come next. Well, if they want you to factor this, again, you can't factor an equation, a quadratic, unless it's equal to 0. So we're just going to set it equal to 0, because that's what they want to find. They want to find out where that penny drops, where the elevation is 0. That's why there's a 0 there. Now you might be stressing out because we haven't seen this yet. Notice there's an x squared, there's no x, and there's a constant. But we're going to kind of approach that when we get to it. So step 1, make sure it's equal to 0. Step 2, make sure it's in standard form. Step 3, make sure if there is a GCF, you take it out. So I think there is 2 GCFs here. 16 times 10, 15, 16. I think 16 times 16 is going to be 256, if I'm doing that right in my head. So right now there's going to be a GCF of 16, but remember that leading coefficient of x squared, that leading term has to be positive. So I need this to be a positive x squared. In order to make that happen, I not only have to take out a 16, I have to take out the negative as well. Because again, the rule is that leading coefficient inside your quadratic has to be positive. So negative 16 divided by negative 16 is 1. 256 divided by negative 16 is negative 16. All right. At this point, you can think about this as x squared plus 0x minus 16. There's other ways to do this problem. There's other ways to think about it. I think this just kind of makes the most logical sense. There is no x here, right? There's an x squared, there's a constant, but there's no x term. That's why we're assigning it as 0x. So same idea. We'll set ourselves up with a cross. A times c, that's negative 16. What 2 numbers multiply to negative 16 but add to 0? I think it's 4 and negative 4. Our a value is 1. So again, you can go back and divide by 1, but it's still going to be 4 and negative 4. So our answers are going to be x equals the opposite of positive 4 is negative 4. And then x equals the opposite of negative 4 is positive 4. But I think what we have to do is go back and look at this in context of this problem. If you go back and look at this and see what it's saying, it's talking about where x is the time in seconds since the penny is dropped. If your 2 answers are negative 4 and positive 4, can you drop a penny after negative 4 seconds? Right? It doesn't really make sense. So in this case, this actually only has 1 answer just because of the context of the problem. You can't do something after negative 4 seconds. So that is not one of my answers. So the only answer I would keep is x equals positive 4. After 4 seconds, the penny will hit the ground. All right, looks like we're about halfway there. This is a long lesson. 31, identify the intervals in which the quadratic function is positive. So what they want you to do here, again, you can go back and look at what was it, example 5. They want you to factor it and then think about it. So I will show you the method that they used in the book, and I'll kind of use the method that I would use, just kind of using common sense. So 31. Y equals x squared plus 9x plus 18. We need to factor this, so I'll rewrite that and set it equal to 0. It's in standard form. There's no GCF. I'm ready for my cross method. A times c, that's 18. B is 9. 2 numbers that multiply to 18 and add to 9 are 6 and 3. My a value is 1, so if I divide by 1, it's still 6 and 3. So my 2 x-intercepts, where this is going to cross the x-axis, is at negative 6 and negative 3. But remember, they're not asking you when it's going to cross the x-axis. They want to know when your function is going to be positive. So just a quick reminder, when a function is positive, what they're talking about is this right here. A function is positive when it's above the x-axis. They're talking about when are the y values positive. A function is negative when it's below the x-axis. So all of these y values below the x-axis are all negative. All the y values above the x-axis are positive. That's what they're referring to when they're saying positive or negative. So it wants to know when they're positive. Well, let's kind of think, okay, so we're going to look at the way the book did it first. So if you graph this function, it's going to have x-intercepts at -6 and -3. You know that it's positive because it's a positive x squared. So it's got to look something like this. I mean, not exactly, but you know, it's going to look something like that. So the way the book wants you to do it is to take these intervals in between the x-intercepts. So they want you to look at interval 1, interval 2, and interval 3. So for interval 1, they want you to just plug in a number that's in interval 1. So if this x-intercept is -6, this one is -3, plug in something that's less than -6. I don't know, -8. It doesn't really matter what you plug in. So for interval 1, I'll plug in -8, as long as it's less than -6. And let's see if my number is going to be positive or negative. So -8 squared is 64. -8 times 9, that's -72. 64 minus 72 is -8. -8 plus 18 is +10. So I don't really care that it's positive. I don't really care that it's 10. I just care that it's positive. So I know in interval 1, that's going to be a positive part of my function. Interval 2, that's between -6 and 3. So pick any number between -6 and 3. It doesn't matter. I'll pick -5. So -5 squared plus 9 times -5 plus 18. -5 squared is 25. 9 times -5 is -45 plus 18. 25 minus 45 is -20. -20 plus 18 is -2. But again, the negative is what counts, because when they're saying, is this function positive or negative during this interval, I know that this function is all negative because it's below the x-axis. So in interval 2, I'm going to call that negative. And then for interval 3, pick a number that's greater than -3. So like I'm sorry, 0. I think 0 is going to be the easiest. So that's greater than -3. So I'm going to plug in 0. 0 squared is just 0. 9 times 0 is 0. So it really just gives me +18, which again, the information we want is that it's positive. So identify the intervals in which the quadratic function is positive. You would say it's positive. You could say something like this. When x is less than -6, right? That's up here in interval 1, when x is less than -6, or when x is greater than -3. As you know, there's different ways to write this. I think that's okay to write it in notation like that, just as long as you can identify where it's positive and where it's negative. All right, it's 32. (32) is y equals x squared plus 2x minus 8. I'll set this equal to 0. There's no GCF. I'll factor it. A times c at the top, b down below. Two numbers that multiply to -8 but add to 2 are -4 and 2. I'm sorry, 4 and -2. Let me double check myself so I'm not screwing it up. 4 minus 2 is +2, so that works. My a value is 1, so I know that my two x-intercepts are -4 and +2. So here's how I think about this. If you understand that those two x-intercepts are at -4 and +2, and if you look, you know that a parabola looks something like this or like this. It's all dependent on if your function is positive or negative. If it's positive, it looks like a happy face. If it's negative, it looks like a frowny face. So this function is positive, right? That's a positive 1x squared. So I know in general, it's going to look something like this. And if it helps you to sketch it out, you can. But if they want to know when this function is positive, again, they want to know when it's above the x-axis. We'll take a look at it. When this function is less than -4, once you pass that line, x equals -4, it's above the x-axis. So when x is less than -4, you can see when x is between -4 and 2, it's all below the x-axis. But when x passes and goes beyond +2, right? When x gets to like +3, +4, it's all above the y-axis again. So when x is greater than 2. So doing all this junk where you're plugging everything in and calculating numbers, it's not necessary at this point. You can make sure that makes sense how you're plugging in those values to test them to see if they're positive or negative. But just thinking about it logically, if you know the function's positive, you know what the two x-intercepts are, you could sketch it and just kind of figure out the point where they're positive or negative. All right, 33. So I'm going to set this up already instead of rewriting y equals. So I'll do x squared minus 5x minus 24. And like I said, instead of writing y equals that, I'm going to kind of skip a step and just write equals 0. No GCF. I'm ready for my cross method. A times c at the top, b down below. I think this is going to be -8 and 3. Two numbers that multiply to -24 and add to -5. Again, you go back and divide by a. A is 1. So don't get in the habit where you're constantly skipping that. Sometimes it's kind of good to just stick with that motion just so that way you're always used to it. And so my answers, my x-intercepts are going to be +8 and -3. This function is positive, so I know if I sketched a graph at -3 and +8, it would look something like that. So all of my x values that are less than -3 and all of my x values that are greater than +8 will make that a positive function. (34) -x squared plus 4x plus 12. Again, just like with 33, I'll kind of skip a step just to make it go a little bit quicker. I can't factor anything until it's equal to 0 and that leading coefficient is positive. So right now, that is an issue. So what I'm going to have to do is take out a GCF of -1, and then I'll be able to factor it. So -x squared divided by -1 is just x squared. 4x divided by -1 is -4x. 12 divided by -1 is -12. And now I am ready to factor. Two numbers that multiply to -12 and add to -4. I would divide by a, but it's just 1, so it's not going to change anything. So my answers are going to be x equals 6 and x equals -2. So if I draw myself a little graph, -2 and 6. But if you go back and look, this function is negative. It's going to be a frowny face. So it's going to look something like this. That's the overall orientation of it. So it wants to know when this function is positive. Well, it's not going to be like the 3 from before, because remember, when I get less than -2 or greater than 6, it's all negative. It's only positive when you're between the two values. So I would say from -2 all the way up to 6, it's positive. You wouldn't want to include those values because at x equals -2, it's technically 0. That y value is 0. 0 is not positive or negative. So you don't want to include them. They're always going to be less than or greater than. Okay, set it equal to 0. Take out a GCF. There's a greatest common factor here. I can divide all 3 of those terms by 2. Now I can factor this. A times C, 1 times 9 is 9. B is 6. 2 numbers that multiply to 9 and add to 6 are 3 and 3. My A value is 1, so I'm not going to go ahead and divide by 1 because it's the exact same thing. So x equals -3 and x equals -3. So when I graph this function, it's a positive function, and technically there's only one x-intercept. There's only an x-intercept at -3. So what that's telling me is that there's a vertex at that point. Okay, the vertex, the bottom part of that parabola is right at -3. So when is this function positive? Basically from when x is less than 0 or when x is greater than 0. Because remember, I don't want to, I don't know why I wrote 0, -3, sorry. X is less than -3, x is greater than -3. There we go. Remember, I don't want to include -3, so it's not like I can say all real numbers because at -3, my y value is 0. That's not positive or negative. So I wouldn't want to include that. Of course, there's different ways to write that, right? There's always different ways to write and annotate things. So if you're online, like looking at something, you might see it annotated a different way. I guess you could also say something like this: x cannot equal -3, right? That would be acceptable as well. As long as you're getting across the point where x can't equal -3, but it can equal everything else, you're good to go. 36, 5x squared minus 3x minus 8. It's equal to 0. It's in standard form. There is no GCF. A times C is -40. B is -3. 2 numbers that multiply to -40 and add to -3 are going to be -8 and 5. I do have an A value here, so don't forget to go back and divide by 5 and then simplify. -8/5 can't reduce, it can't even simplify, but 5/5 is the same thing as 1. So my answer is going to be x equals 8/5 and x equals -1. So if I go and graph this, it's a positive parabola. Here are my x-intercepts at -1. 8/5 is like, 1.6. So we'll just, I don't know, it doesn't really matter where you put it, but it's something like that. It's a positive parabola, so it goes like this, very similar to the first 3 problems that we had. So when is this positive? Well, when you're less than -1. And then the other part, once you pass positive 8/5, that function is positive. So when x is greater than 8/5. All right, I'm running out of paper. So many problems here. 37. Write an equation for each parabola. So remember, this is the one that was a little bit tricky. If you go back to example 6 on page 91, this is that one where you're using kind of that funny factored form, that algebraic definition of a factored form equation. And then what you're going to do, instead of P and Q, you're plugging in your 2 x-intercepts. So we're going to plug them in and then simplify. because when I subtract a negative, it's the same thing as adding. Once I simplified that, you'll notice that the only thing that's missing here is just a. So we have to solve for that. So that's why they give us this point, negative 320. So x is negative 3, y is 20. So we plugged in negative 3 for x, we plugged in 20 for y, we did a bunch of math, solve for a, and then put it all together. All right, so here we go. I think this is the final stretch. So 37. Probably with x-intercepts at -1, 0, and 3, 0, which passes through the point 1, -8. So what we're going to do is write y equals a, and then it's x minus your first x-intercept. So that's at -1. And then I'm going to multiply that by x minus the second x-intercept, which is 3. So now we simplify. When I subtract a negative, it's the same thing as adding. And now I'm just subtracting 3. So not too bad. Plug in your two x-intercepts. Now they're giving you that third point. It passes through the point 1, -8. So if I'm going to pass that through 1, -8, my x is 1, my y is -8. So go through here and replace everything with what we just said. So y is -8, x is 1, and then do your math. Follow PEMDAS, right? Parentheses, so what's inside parentheses, knock that out first. 1 plus 1 is 2. 1 minus 3 is -2. Then we'll do multiplication from left to right. 2 times -2 is -4. But that bugs me when I have a coefficient of a behind it, so I'm going to rewrite this and write -4a. And now to solve for a, I'll divide both sides by -4. So I get a equals 2. So what we're going to do is we're going to go back to the step where we simplified it, which is right here. And we're going to keep that entire step, but we're just going to replace a with 2. So it's y equals 2, x plus 1, x minus 3. (38). Parabola with x-intercepts at 0 and 1, and that passes through the point 2, -2. So y equals a, an x-intercept at 0 and at 1. So it's x minus 0 and x minus 1. That's already simplified. There's nothing we have to do to kind of clean it up. So I think we're good to go there. And now it's going to pass through the point 2, -2. So we're going to replace the x's with 2 and the y with -2. 2 minus 0, 2 minus 1. Now simplify. Inside the parentheses, 2 minus 0 is 2. 2 minus 1 is 1. So 2 times 1 is just 2. I just kind of, you can see that I flip-flopped them just right off that step, right? So 2 minus 0 is 2. 2 minus 1 is 1. 2 times 1 is 2. But instead of writing -2 equals a times 2, that bugs me. I like my numbers up front, in front of the coefficient, or in front of the variable. So I'm going to write it like that. Now if I want to solve for a, I just divide both sides by 2. And I get a equals -1. So again, this is the step that's simplified. So that's the step we want to plug a in on. Y equals -1. X minus 0, x minus 1. You could simplify that actually a little bit further. Instead of writing x minus 0, you could just write x, because those two things are exactly the same. So either one of those would be acceptable. And then we're at an hour and 5 minutes. So let's wrap up this last problem. A snorkeler dives for a shell on a reef. After entering the water, the diver descends 11/3 feet in 1 second. Write an equation that models the diver's position with respect to time. So it looks like, if I'm reading this right, their first, when they break the water, is at 1 second. And then when they come back and touch the water up top, it's at 11 seconds. So to me, that's telling me at 1 second and then 11 seconds, those are my two x-intercepts. After entering the water, the diver descends 11/3 feet in 1 second. So I think that's giving us our point. So after 1 second, they've gone 11/3 feet. 1 second, 11/3. That's kind of a little hard to put together. Make sure you're watching. Let me put this on the screen. What they're talking about here, they're saying write an equation that models the diver's position with respect to time. So that tells you that your time is your input. It's your x value. And you could see that down here as well. They're putting x first, then y. So that's how I knew that I should have put 1 second in front and then 11/3 feet as my y value. So same old, y equals a. It's x minus 1. And then the other one is 11, x minus 11. Now we can plug in that point. X is 1, y is 11/3. So x is 1, 11. That's an 11. Now we can simplify. 1 minus 1 is just 0. 0 times anything is going to be 0. So I think on the right, actually, let's just work this out. 1 minus 11 is -10. So what I have is this. Now if we follow PEMDAS and keep working, 0 times -10 is 0. And then, did I mess something up here? I don't feel like that should be 0. Let me go back and just double check this real quick. 1 second, 0 feet, 11 seconds. Oh, yeah, I did. I screwed this up. Let's go back and look at this real quick. So they're saying that the diver enters the water. They enter the water at 1 second, and they're 0 feet at 1 second. Up in this description, they're saying after entering the water, so a second has already passed, the diver descends 11/3 feet in 1 more second, or in 1 second. So technically that should be a 2. Let me kind of switch this around. Hopefully that makes sense. The x-intercepts are 1, 0 and 11, 0, but the story problem is saying after entering the water, which a second had already passed, then the diver descended 11/3 feet in 1 more second. So that should be 2 seconds. All right. Let's fix this. I'll change that to a 2. That's still, I'm sorry, that's not a 2. Let's just start back over. I can't fix my work. Y equals a, x minus 1, x minus 11. Now I'll plug in my x and y. My x is 2. That's looking better. Okay. Now I'll simplify parentheses. So 2 minus 1 is 1. 2 minus 11 is -9. A times 1 times -9. That's -9a. A couple ways you could do this. I think the easiest way, just to make it easy on people because they're not used to dealing with fractions, this is 11/3. So what I can do is I can multiply both sides by 3, and that'll get rid of my fraction. So 3 times 11/3, those 3's cancel each other out, and I'm left with just 11. Negative 9 times 3 is negative 27. And now I can divide both sides by negative 27. And I end up with A equals negative 11/27. So my final answer, I'll write this down here. Which step? There we go, right there. So it's y equals negative 11/27 times x minus 1 times x minus 11.